Hey folks, how we doing? It's Mr. Carter here, ready to do math lesson for 3 with all of you today. It's a lesson on partitioning rectangles, and let's begin. All right, so our learning target is this. I understand how to solve multiplication problems by partitioning rectangles. It's a pretty simple learning target. Okay, so let's figure out how we're going to do that. So today our math message is going to ask you to go to page 111 in your math journal. So why don't you go ahead and take a look at that, find your math journal, pause the page, pause the video, go on page 111 in your math journal, and come back once you figured it out. Okay, welcome back. So the question said this: Maya wants to lay tile on a floor that's 8 feet wide by 24 feet long. The tiles she wants to use are 1 square foot each. How many tiles will Maya need? Well, if you figured it out, you should have gotten around 192 tiles. So what are some ways we can solve this problem? Well, I drew here the 8 foot by 24 foot square tile floor that she wants to lay down here. So you could have done one thing. Well, you could have sat there and you could have counted every square one at a time, but nobody's got time for that. Or you could have done repeated addition, where you could have went 24. You could have counted every row, so 24 plus 24 plus 24 plus 24, 8 times, right? Well, that also sounds like a lot of work. So we know when we're figuring out the area, which essentially is what we're doing, here's we're finding the area of this piece of floor here, we know that we could multiply to find the answer. Well, 24 times 8. Well, that we haven't really done a whole lot of 2-digit times 1-digit problems yet. So I'm going to teach you a strategy today on how to do those types of problems using partitioning rectangles. So here we go again with my drawing of the 8 square by 24 square tile floor, right? So it's 8 feet wide by 24 feet long. So I'm going to put my 8 here to represent the 8 feet wide. But what I'm going to do is I'm going to break apart this floor into manageable pieces. So I'm going to start here with an 8 by 10 section. So it's 1, if I count my squares here, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I have an 8 by 10 section here. And I have another 8 by 10 section here. And that leaves me here with an 8 by 4 section, right? Because when I add 10 plus 10 plus 4, that gives me 24 feet. So that is how long our section of flooring is, right? So it's 8 by 24. But I partitioned this rectangle, we're going to call it a rectangle, into manageable pieces. So I know that if I did just this section here, I would have to go 8 times 10. Well, we know, because we did extended multiplication facts already, that 8 times 10 equals 80. So that's that. So now we're going to go to this section here, which again is an 8 by 10, right? So if I count 1, 2, 3, 4, 5, 6, 7, 8, this is by 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I know that again, I'm going to have 80 squares here because 8 times 10 is 80. Now we just have this small section left. Well, this one's an 8 by 4, right? And we know that 8 times 4 is 32. So this section here has 80 tiles. This section here has 80 tiles, and this last smaller section here has 32. So now what? Well, we're going to combine all of these sections together, right? So we're going to take the 80 that is here, and I'm just going to put it over here, because what we're going to eventually do is we're going to be adding all these sections together, right? So I'm going to take this 80, and I'm going to put it over there, and then this 32 over here. And then what we're going to do is we're going to add those 3 smaller sections together. And when I do that, I get 192. All right, so this is how we partition our rectangles to find an answer. Well, we could have, so 24 times 8, which is what our original problem was, is 192. All right, so let's look at this problem again, but this time we're going to separate it into, partition our rectangle differently. So instead of going into by tens, I'm going to take this and I'm going to make a bigger section of 20. So I'm going to go 8 by 20. And then I'm going to take this last section, which is 4, right? So 20 plus 4 is 24 again, right? Because now we're doing 24 by 8. But again, I'm breaking it apart into smaller, more manageable pieces. So this section here is 8 times 20. That gives us 160 squares, right? In this section here. And again, this section here is going to be our 8 by 4, which is 32. So once again, we're going to add our smaller sections up. So I'm going to take 160, put it over here to the side, and I'm going to add 32 to that. And that'll give me, again, 192. So again, 24 times 8, because again, we're going 20 plus 4, 24 times 8 is 192. All right, so let's get ready to do some more math. Here's another math problem. Jacob rode his bike 4 miles a day for 39 days. How many miles did he ride in all? Well, again, we're going to have to multiply to figure that out because we're going to go 39 miles times 4 days. I'm sorry, 39 days times 4 miles, right? So we're going to go 39 times 4. Now, even though this is not an area problem like the last one where we were trying to figure out the area of a tiled floor, that we could still use partitioned rectangles to solve this. So 39 times 4 equals, I just put m here for miles, or unknown as miles, because we don't know that answer just yet, so I just put m for miles. So here's our rectangle, and I'm going to put our 4 here on this side. So going 39 times 4. So I'm going to put 4 here, and I'm going to break apart this rectangle into smaller manageable parts. So 30 plus 9 equals 39, right? 30 plus 9 is 39. So I'm going to do here, so 30 times 4 in this box here, that I know equals 120. So now over here, I'm going to have to go 9 times 4. That gives me 36. So now we're going to have to add both of these boxes here together to get the whole piece, right? So we're going to go 120 plus our 36 to get 156. So, my friends, 39 times 4 equals 156. Now, are there other ways you can partition that rectangle? Well, yeah, of course there is. So let's go through those ways. So we're still doing the same problem, 39 times 4. So I'm going to put my 4 here. This time I'm going to break apart my rectangle into 10 plus 10 plus 10 plus 4. Because again, 10 plus 10 plus 10 plus 9, I'm sorry, 39. So it's 39 times 4. So again, I'm breaking that bigger number into smaller manageable pieces. So 10 times 4 is 40 in that square. Again, 10 times 4 over here is also 40. 10 times 4 again is also another 40. Plus 9 times 4 is 36. So now you got to add your small boxes together. So I'm going to go take that 40 and go 40 and put it onto the side. I'm going to add another 40, which is this 40 here. And then I'm going to add one more 40, which is that 40 over here. And I'm going to add 36, which is this part here. When I add that all together, I get 156. Same answer, same problem. 39 times 4 is 156. Same problem, just broken up a little different. Look at this. I'm going to do the same problem again, differently. 4 on the side again. But this time I'm going to go 20 plus 10 plus 9, because 20 plus 10 plus 9 also equals 39. So in this square here, I'm going to go 20 times 4, 20 times 4, that equals 80. Here in this square here, I'm going to go 10 times 4, that equals 40. This square here, again, I'm going to go 9 times 4 equals 36. So now I'm going to add these three answers together. So I'm going to go 80 plus 40 plus 36. And again, the same thing, equals 156. So again, 20 plus 10 plus 9 is 39 times 4. So it doesn't matter, that's the whole point of this, is saying that it doesn't matter how you choose to break up the rectangle, it will still come out to be the same answer. You just need to find numbers that you are comfortable with multiplying by. So if you're good with tens, use tens. If you're good with 20s and like those extended multiplication facts, feel free to do it that way too. Doesn't matter, how you break it up, as long as you get the same answer. So cool. All right, so now I want you to go to page 112 in your math journal, and I want you to try some of these problems. So pause the video, go to page 112. I want you to work out questions 1, 2, and 3 together by yourself, and then figure that out. And then we'll go over the answers together. Okay, welcome back. So the question 1, 5 times 48. Well, here's a sample answer. They decided here to go break the 48 apart into 40 and 8. 40 times 5 is 200. 8 times 5 is 40. So then 200 plus 40 is 240. You may have chose to break up your rectangle or partition your rectangle a little differently. As long as you get 240, it doesn't matter how you broke apart your rectangle. All right, so, I guess let's look at questions 2 and 3. There we go. All right. So 2 was 63 times 9. So again, they chose to go 60 and 3. That's how they broke apart. They partitioned the rectangles. So 60 times 9 is 540 because that's an extended fact. 6 times 9 is 54, and then you add the 0 here for the extended fact. 3 times 9 is 27. When you add 540 plus 27, you get 567. Again, they broke it up this way. You may have done it differently. Look at 3. It was 37 times 7. So they broke apart the 37 by going 30 and 7. And then they go 30 times 7 here is 210. 7 times 7 is 49. When you add 210 plus 49, you get 259. All right, let's look at that last problem. Kadir solved 75 times 8 like this. So again, you can see how he broke it apart, 75 times 8. But Ariadne, I think is how you pronounce it, solved the same problem like this. She did it 30, 30, 10, and 5. So take a minute, answer this question. What is similar about their solution strategies and what is different? So make sure that you're talking about how they are similar and also talking about how they are different. Pause the video, write down your answer, and then we'll go over what that looks like. Okay, welcome back. So here's a sample answer, and you may have gotten something like this. Well, they are similar because both Kadir and Ariadne partitioned the rectangles. They both used partitioned rectangles to solve this multiplication problem. So that's how they are similar. They are different, however, because Kadir used the expanded notation to decompose 75 into tens and ones. So he just simply did the tens, which is 7 tens or 70, and 5 ones, right? However, Ariadne did it differently. She composed it to different smaller parts, right? So again, they got the same answer, but they just chose to break apart their rectangle a little differently. All right, friends, this was partitioned rectangles. Hope this was helpful. Reach out to your teacher if you have questions. Take care.